Hello, and thank you for joining me for another episode of Software Design Patterns. Today we're going to be going over the adapter pattern. So the adapter pattern is useful whenever you have two components that you want to work together. Usually it's two classes that you want to work together, but for whatever reason their interfaces don't match exactly. And so really what that means is that what one class expects, the other class doesn't really do to the same. It does it, but it doesn't do it in the way that is expected. So let me just skip to the diagram, and it makes a ton more sense. And I mean, it'll make a lot more sense whenever you see the code. So in this case, this is the diagram. So it only has 4 components to it. The client really wants to work with the service, but maybe the service doesn't do things the way the client expects. And so one simple example of this is when the service has a different type of arguments than the client is able to provide. The conversion logic, usually you don't want to do that in the client. You want to do that somewhere else because it's not really the client's job to convert its arguments for the service. It's more important for the client to know how to use the service. So I'm not going to rename things in this case just because it's much simpler to show the code. So I'm just going to skip over to Eclipse here. So what we're going to have is we're going to have a main class, and this main class is going to provide 2 arguments to our client. It's going to provide 2 strings. One is a 3, one is a 4. And the client is going to do some math with these strings. It's going to do some math with the numbers in these strings. So one way to think about this is maybe we have some kind of framework, and this framework is represented by the main class here, and it reads in, arguments as strings. Maybe it, takes them from the command line or something. The important factor here is that it provides them as strings, and we're not going to be modifying the main class. We're going to assume that it can't be modified for various reasons. So we have the client, and so this client, it creates a new instance of the service. In this case, we're going to call it calculator. We'll rename service in a minute to make it look a little bit better, but this do something logic is not super crazy. All it does is it calls calculator.add on the 2 numbers that it gets. Remember, we're accepting the numbers as strings, and for just for the purposes of a contrived argument, we're not going to be modifying their type. So, just changing this to int is not allowed. The calculator, its method signature has int and int. We'll go into the calculator in just a minute. But that's why the compiler is complaining here, is it's saying, hey, I can't do anything, you're passing in strings, but I want integers. The formatting logic here is not super terrible. All it does is it just prints. This is just a string.format. If you don't know how this works, it's super simple. It'll just print number A, number B, and then it'll print A plus B in here. So we'll get, 3 plus 4 equals 7. Same thing with the multiply. So if we go into the service now, we're also going to assume that this service is some kind of legacy component and that we can't modify it either. So it has to accept integers, and there's just nothing we can do about that. But yeah, as you can see, it's super simple. It just returns A plus B and A times B. So we're kind of in a situation where the only place we can do our modifications is in here. Now, some of you might say, okay, well, what we can just do is we can say, var int A equals, integer dot parse int, and then we can say number A. Then we can pass in, int A, we can do that for int B, and then we can pass in int A and int B in here. And so what you would end up with is you'd end up with a method that says, convert arguments, and then you might say do math. So one of the problems that you have here is that you have a method that has 2 sections to it, right? So that usually means that the method is doing 2 things, which is bad design. So what we want to do is we want to avoid doing this conversion logic inside of the client. The client does not care about the conversion logic. All it cares about is what it's doing with this calculator. So for the sake of argument, let's rename this service to legacy calculator. I know we said we weren't going to modify it, but this is sort of an exception. And so if we go back to the diagram here, what you'll notice is that we're kind of missing, whoops, that's not the diagram, is that we're missing 2 classes. We're missing the client interface, and we're missing the adapter. So let's go create those really quick. So basically, the client is not going to want to use the service directly. It's going to want to use a client interface. And so we'll just create a new interface. We'll call it calculator. And so the client is going to want to call add on the client interface but it's going to want to call it with two strings, right? So we're going to say that the calculator interface, the first method returns a string, it's called add, and it takes string number A and string number B as the arguments. Okay, and so what we can do is we can copy the name of calculator and we can replace legacy calculator with it, because now we're using the calculator interface instead of the legacy calculator. We're going to get a compile error saying that it doesn't conform to that interface. That's fine. But what you'll notice is that once I get rid of that, the compiler says, oh, okay, the add method works now. That's fine. Now it just doesn't like the multiply. So what we can do is Eclipse will actually suggest a refactor for us, and what it's going to do is it's going to add the multiply with two strings as arguments into the calculator interface, which is something we want to do. And it'll take us over there, it'll name everything the way that we want. The only change we're going to make is instead of returning an object, we're going to return a string. Okay, so now the client is completely happy. It says, okay, yeah, I can use the calculator. But if we try to run this, what we'll get is we'll get a null pointer because we never actually create an instance of calculator here. And since calculator is an interface, we can't create an instance of it directly. We actually need a class that implements it. So what we'll do is we'll create a new class, and we'll call it the calculator adapter. And so what that will do is it will implement the calculator interface. So we'll say, okay, that's fine. Now we just need you to implement the methods from that interface, which are the add and multiply. So now we want to do our parsing logic in here. However, we don't want to be doing the math in here because we already have something that can do the math and we don't want to duplicate the code, right? So what we want to do is we want to create an instance of the legacy calculator. Calculator. And we're going to set that equal to a new instance of the legacy calculator. So we're still using our old legacy code, but what we need to do is we need to say var int a equals integer dot parse int, and we're going to parse number a, and we're going to do the same thing for number b. And again, if you're not familiar with the var keyword, all it does is it just infers the type. So since parse int returns an integer, which it's not showing now, int b will have the type of integer. And so what that will let us do is then we can say return calculator.add, and now int a is an integer, and int b is also an integer. Okay, now what this complains about is this says, hey, this add method returns a int and we want a string. You've declared a string up here, so that's an error. A quick way to convert an int to a string in Java is to just type the empty string like that and use the plus sign. And what that'll do is that'll convert this integer to a string. You can also do string.value of, value of, if I can ever type it. And you can use value of int. I think it's just simpler to type out this version of it. And so we're going to copy and paste this into here, and we're just going to call calculator.multiply. You can argue that this logic is duplicated, but we're just going to ignore that argument because it's not really relevant right now. It's a minor amount of duplicated logic, it doesn't really matter. And so here, the calculator adapter actually conforms to the calculator interface now, so we can say new calculator adapter. And so, yeah, once we run this, as you will see, it will actually execute now. We run as a Java application, so we get 3 plus 4 is equal to 7, and 3 times 4 is equal to 12. So, I know that was a little complicated, possibly, but what we ended up doing, basically, is we took this legacy calculator and we added this interface to it. We changed its interface to look like this, and the way that we did that is through this calculator adapter class. So it basically just takes this call to add, and it forwards it to the actual calculator to do the work. The result of this is that we can still use our old legacy code, we don't have to modify the component that gives us our arguments, and we don't have to do any extra logic in the client. All of that extra logic got pushed into the calculator adapter. So now you have your separation of concerns, right? Your legacy calculator does the math, your client figures out how to use the legacy calculator to do what the main class wants, and then your adapter converts the arguments so that the client doesn't have to. And so one way to think about this, one way to model this in the real world is with something like, an adapter like kind of cord, right? So you have, your phone or your computer. If you want to charge your phone with your computer, let's suppose you have like an iPhone, you can't just plug it in. You need a USB adapter that will adapt to, the iPhone kind of lightning cable, right? So yeah, that is one physical example of it, and this is the actual programming example. Anyway, I hope that helps. But yeah, if you enjoyed the past 11 minutes of your life, please feel free to like, subscribe, share the video with your friends. If you need more explanation, feel free to comment below, and I will, try to answer what I can. Anyway, thank you for watching.